are the charges that are present? We'll remove this. Initially, what are the charges that are present? Initially, be like a Q naught, we'll take it. Q naught minus Q naught plus Q naught minus Q naught. So what is the charge of system? Q naught should be equal to C naught by 2 into E, because effective capacitance will be in series. Then series effective capacitance will become C naught by 2. So this is a charge in each capacitor. So what is the initial energy in capacitor will be equal to half of the EMF will come. I'll write it in another way, or Q naught square by 2 C naught. 2 C naught. So this will become Q naught square by C naught. What is Q naught? Q naught is C naught E naught by 2. C naught E square by 4. This will be the energy, initial energy in the circuit. What was the initial charge of system? It was Q naught. Finally, after it is fully filled up by the slab, I brought it here. Then capacitance of capacitor will become Kc naught. Or any changes in the charge? Yes, some changes in the charge will be there. So we'll take it that as Q. The capacitance of other capacitor will not change, but the charge in other capacitor has to change. First, we'll calculate the total capacitance. It'll be easy for us. The total capacitance of system will be C is equal to Kc naught by K plus 1. Kc naught into C naught, Kc naught plus C naught. So this will be the capacitance. So then what is the final charge? Final charge will be C into E. So this will be K C naught E by K plus 1. This will be the charge in each capacitor. The final energy in capacitor, final energy should be equal to Q square by 2K C naught, Q square by 2 C naught. Q square, I think Q square 2 C naught. First, we'll bring outside. Okay, this one. This will become 1 by K plus 1. Q square value K C naught E by K plus 1 whole square 2 C naught. This will be 1 plus K by K. 1 K get cancelled. So K, 1 C naught also get cancelled. C naught E square by 2 1 plus K. So there's the final energy. Look at the final energy, increases or decreases. It all depends on K. No, K should be greater than 1, no doubt. The K must be greater than 1. The K must be greater than 1. So put K equal to 3 by 2, check it. Is it UF greater than UI? Put K equal to 2. If you put K equal to 2, C naught E square by 3, C naught E square by 4, the energy got increased, no? K equal to 1.2 like this. But altogether, I should take help of this equation, then I should conclude energy increases or decreases. This will be the capacitance will increase or decrease capacitance. Earlier, what is the capacitance? C naught by 2. Now 2 C naught by 3 will increase, no? Capacitance of system. So like this, they'll ask you in matchings, it will come. If I fill up this, then what will happen to the energy in the circuit, capacitance, charge, final energy. Now, if UF got increased here, who will supply this? The battery. So the battery does positive work or negative work. You have to compare all these things. For that, what you have to do? Just you have to take the initial and final data. With slab not filled, slab after filled. If Q greater than small, if Q greater than Q naught means, what does it mean? The battery did positive work. because the charge, you just look at the charge of this plate. The charge of this plate increase means the battery should push that additional charge. So positive charge leaves, so the battery does positive work. I think we need all the data without, what students are doing is like they are thinking it's a conceptual. You go wrong there. Initial, final. So you have so many best questions available in textbook now. So initial diagram, not all the things. Final diagram, find out one. Then you compare, then you conclude the options. There's a method.